All right, class, settle down, settle down. Today's topic is relative humidity. What is relative humidity? Imagine the air around us as a sponge. This sponge can hold water vapor, which is water in its gaseous form. Relative humidity tells us how much water vapor that sponge is currently holding compared to how much it could hold at that specific temperature. In simpler terms, it's a ratio. It compares the actual amount of water vapor in the air to the maximum amount of water vapor the air could hold at that temperature, and it's expressed as a percentage. 0% means the air is completely dry, and 100% means the air is saturated. It can't hold any more water vapor. The importance of temperature. Here's a crucial point. Warmer air can hold much more water vapor than colder air. So, the same amount of water vapor will result in different relative humidity values depending on the temperature. Alright, let's dive into the formula for relative humidity. The formula is relative humidity in percent equals the actual water vapor content divided by the maximum water vapor content at that temperature and then multiplied by 100. Now let's go through some examples to help illustrate this concept. First, imagine a hot summer day where the temperature is 35 degrees Celsius. The air feels very humid and the relative humidity is 80%. This means the air is holding 80% of the maximum amount of water vapor it can hold at 35 degrees Celsius. You'll likely feel sticky and sweaty because the air is already saturated and can't easily absorb more sweat. Next, picture a cold winter day with a temperature of 5 degrees Celsius. The air feels dry and the relative humidity is 60%. Even though the relative humidity is quite high, the actual amount of water vapor in the air is much lower than on the hot summer day because cold air can't hold as much moisture. This is why your skin might feel dry in winter. Lastly, let's talk about the dew point. The dew point is the temperature at which the air becomes saturated, or 100% relative humidity, and water vapor starts to condense into liquid water, or dew. If the temperature drops to the dew point, you'll see dew forming on grass or other surfaces. Now, let's look at some real-life applications of relative humidity. First, in weather forecasts, relative humidity is a key component. It affects how we feel the temperature, often referred to as the feels like temperature or heat index. In agriculture, farmers use relative humidity information to determine when to irrigate crops, ensuring they provide the right amount of water. For indoor comfort, maintaining appropriate relative humidity levels is important for health and comfort. Low humidity can cause dry skin and respiratory problems, while high humidity can promote mold growth. In conclusion, relative humidity is a useful measure that helps us understand the amount of moisture in the air. Remember that it's relative to the temperature, so the same amount of water vapor can result in different relative humidity values depending on how warm or cold it is.